Okay, well, thank you. I'm happy to represent this fantastic mission on the behalf of the entire team. Um, so let's go, since you got the status from Thomas Wagner this morning, I don't have to tell you about the current status, but I will come back to that a little bit at the end. Okay, so we address these fundamental questions, some of which have been spoken about quite a bit already this week. But, we address this question of, are the tessera felsic, iron poor, silica rich, and fingerprint of past oceans, which is, it's also important for understanding the evolution of Venus. Is it the only planet that has these massive continent analogs and thus secondary crust besides Earth? And volcanic history, we just chatted about that. So, understanding the rate of volcanism that's occurred over time, was there a catastrophic event or not, is very important for the atmospheric history, the geologic history, and the interior evolution. So a really big question that we will address and answer. Subduction, near and dear to my heart. It's the first step in creating plate tectonics on the Earth. It happened billions of years ago here. And there's little data, a lot of theories. And so we have an opportunity to go to a planet where it may be active today and understand the conditions that allows subduction to initiate, helping us understand the early evolution of plate tectonics, which, is increasingly linked to understanding Earth's long-term habitability. Heat flow, I talked about this on Monday, and I showed you the crazy looking elastic thickness maps. Obviously there's a lot of activity going on in the lithosphere that is not resolved by present day gravity. So we really want to get the much better gravity field to be able to really address what are the variations on the small scale of elastic thickness, understand, do we really believe that the very large values of elastic thickness, and better topography to be able to see if there's flexure and some other features as well. Okay, and in the interest of time, I won't walk through all this, but these are all factors for rocky planet habitability that this NASA report and others have addressed. I'll just mention the magnetic field, of course, important for understanding habitability. The core size is very poorly constrained right now, and we'll get a great measurement of that and be able to really get at constraints on composition, which will help us understand what's going on with or without a dynamo, or possibly a very low level one. And okay, so Candy had a nice list of things she wanted us to cover. These are our goals and objectives. I talked about the rocky planet evolution ones mostly, except for B, and that's the record of prior geologic regimes. The great topography we have for Mars, the Moon, Mercury. We've seen evidence of buried impacts there. And with gravity data, we've seen evidence of past tectonic features. So we'll use those data sets to see if we can see anything underneath these volcanic plains that will give us a hint of prior activity. I'll talk a lot about the active processes in a minute, and I've already mentioned the past and present water in the sense of the chemical fingerprint, possibly in the tessera of past water, and the VEM instrument will look for water being outgassed near the surface from volcanoes. And I'll talk about instruments on the next slide. Oh yes, yeah, sorry. So I also, one of the things Candy mentioned is what can the community do? So we have two instruments that are not global, and two observations that are not global. One is the repeat pass interferometry, which will look for surface deformation, and those are very precious targets. We have a dozen or more. So of course, the community is very interested in what things are active. And so, we'll need to have a community debate about what could be active and what are the best targets for those observations. And the SAR imaging, the high resolution at 15 meters, is about 25% or more of the planet. So we have them focused on these objectives, but there'll be an opportunity to suggest targets for that high resolution imaging as well. So here are the instruments. The radar is the Venus Interferometric Synthetic Aperture radar from JPL with contributions from the Italian Space Agency. We get a global DEM at 250 meters, 5-meter vertical resolution. That's over 90% of or more of the planet. 30-meter resolution global imaging, the high resolution, as I said, 27% or more of the planet. When we look to make the first interferometric deformation maps, we'll look for surface change using the VISAR instrument, between Magellan and Veritas and Vision, as well as, intercycle with Veritas. Okay, so the VEM instrument, we've heard a lot about spectroscopy this week. And one thing I think people don't really appreciate is the difference in the SNR that we'll get with VEM versus the Vertis instrument. The SNR for Vertis was, in the single digits. We'll get vastly better SNR, as well as, many different bands in VEM. So this is, basically the first spectrometer ever designed to observe the surface of Venus. Vertis gave us fantastic information, but it was not designed to observe the surface. So, I think we'll really be able to see a lot more about the surface rock type. And we'll, of course, use it also to look for volcanic activity, both the thermal signature and this chemical signature of recent volcanism, however recent that is. Gravity science, we'll have a much better gravity field resolution with nearly uniform resolution, 155 kilometers, 3 milligal precision. We'll get some great geodetic measurements. We expect to be able to get core size to about 50 kilometers. Okay, so just coming back to this for a moment, Candy asked about what instruments do you need to address your science objectives? And so there's a key, VISAR, VEM, and gravity, and that on the right and on the left, those letters to show which ones contribute to these goals and objectives. We pretty much need all the instruments or many of the instruments for these objectives. The only one we just need VEM for is to look for water coming out of volcanoes. Okay, I think we've talked a lot about surface composition, so I can probably skip this one. Are there analogs of continents on Venus? Volcanism, yeah, so we were just talking about this question of catastrophic, a major event versus ongoing smaller events in different regions over time. We will address this by looking at the impact craters. This shows a flooded impact crater. We don't know what's in the bottom of those. This one, we can see that it's lava flooded in, but for the most part, we don't know. Could it be alien sediments making craters dark? Is it volcanism? We're also going to look for impacts in the tessera. The stereo data showed an example of a deformed crater that we hadn't seen previously. And I'm guessing that we'll see many more in the topography as well. So I think we're going to look to try to see if we can detect additional impacts on the surface of Venus as well to give us better insight into the history. Okay, so change, yeah. So on the far left there is surface interactions of the atmosphere with basalts on Hawaii. So chemical interactions occur super rapidly under air. We don't know how that translates to Venus, but we'll look for those chemical changes and the thermal changes. So yeah, we'll use all these different ways to look for evidence of both tectonic and volcanic activity on the surface. Okay, so data sets. These are the list of the data sets that Veritas acquires. And this kind of gives you a hint of what the topography might reveal. Of course, every time we've gone to Mars with order of magnitude increase in resolution, we've seen things that we never anticipated. And I fully expect that Venus is even weirder than we might think. Okay, so one of the questions is about synergy, and there's like just so much synergy between these three missions that I thought I would put it down on a slide, and because there's just a whole lot of things that I probably would forget. But Da Vinci has spectroscopy and imaging, and those are really great complement. We'll be able to use those data sets to better interpret the Veritas radar and imaging, and our global data sets will put the Da Vinci observations into context. They measure volcanic gases. We look for global volcanic outgassing of water, hopefully, and the roughness that we can get from the radar will also be complemented by the Da Vinci imaging. if Veritas topography and imaging were available as well as VEM data, I'm sure it would be of value in the Da Vinci probe. I know they're going to alpha, but it's still would be a value if it were available. They've also asked about cloud observations, and if we were observing at the same time, that would be a nice thing to help interpret the Da Vinci data. Envision and Veritas, we obviously have two radars, different wavelengths. So having radar observations at different scales is a value for looking at surface roughness, increasing the interpretability. Both VEM, there's a VEM-like instrument on both missions, and having the global topography provides more precise emissivity measurements, because the topography and the surface temperature is a function that goes into the data analysis for creating emissivity. To have the global data sets available from Veritas would be valuable for envisioning targeting, so they don't have to focus as much on topography, for example. Obviously, they can do it without it, but it's valuable, and it's helpful to know what they're going to get. Ground penetrating radar, you definitely need high resolution topography to remove clutter. And 2 minutes. Okay, I'm just about done actually. Okay, so yeah, and it'd be great to have Veritas and Envision be in sequence, because it gives us a longer timeline for recent and active volcanism search and for constraining the planet's spin rate. Okay, so I'm just going to talk briefly about where we are with respect to other timelines. So at the top, you see the critical milestones for Da Vinci and Envision, and where we were previously at the top in terms of our timeline, launching in 27. And the two launch opportunities at the bottom are ones that are consistent with a 3-year delay. And we have advocated for a 2-year delay for the following reasons, launching in late 29. At 29, it's deconflicted from all these other critical events, and it allows Veritas and Envision to be in sequence. It allows our primary science mission to end prior to the start of the Envision science operations. And that's good for all of these partners that are involved. It's good for the resources of people, of funds, and it makes it nice for the science as well to have one data set be available to inform the next data sets to be acquired. So, this is something that I think is helpful for a lot of us in the community. It comes out, this would put Veritas before the New Frontiers 5.0, and it would make VEM, not topography, but VEM data available to Da Vinci for alpha, to inform, their final selection of their targeting if they choose to adjust anything. Okay, so that's that's it. Thank you. Thank you.